Last meeting on Tuesday, we started to talk about forces in equilibrium in 2 dimensions. And we said that if we have system of forces, many forces, concurrent forces, and these forces are in equilibrium or in balance, I can say summation of all x components of these forces equals 0. Summation of all y components of these forces equals 0. And these two equations are called equilibrium equations. And these two equations can solve up to 2 unknowns. And we did examples last meeting. I will do more examples today. I will start with this example. I will do 2 examples, 100% solution, and then I will give you a hint about the rest. So we have a weight. I'm gonna assume this weight is not only 20 kilogram, it's 20 Newton, not kilogram. So we have a weight here of this lamp equal 20 Newton. To hang up this weight, we used 4 cables, DE, DC, CB, and CA. And this system of the cables and the lamp and the weight, everything is in equilibrium. So the first step, we have 2 points, point D and the point C. Point C and D are in equilibrium because the whole system is in equilibrium. So let's start to talk about point D, for example. Point D, I will have a weight equal 20 Newton. Looks like this. Any weight for any body in this world must be vertical downward. Then I have another cable in this direction with a force. This force can be called FDE. I have another cable horizontally with a force equal FDC. And keep in your mind the force FDE with angle equal 30. This is for point D. One more time. If you look to this diagram at point D, I should expect a vertical load. I should expect a force in this cable. I should expect a force in this cable. This is what I did for joint D here. Do you have any question? This is the most important step to solve your problem. Keep in your mind also, if you talk about point C, what do you have at point C? I have at point C this force in this horizontal cable FCD. And we have this force in this cable FCB. And we have a force in this cable FCA. Keep in your mind, we are given that for this force, we are given right angle triangle 4, 3, 5. For this force, we are given this angle equal 45 degrees. One more time. At point C, we have a force in this cable. We have a force in this cable. We have a force in this cable. This is all what you have at point C. Does that make sense? Does that make sense? So you will ask me a good question. Why you are taking care of C and D only? We have point A, we have point B, we have point E. I cannot say these points are equilibrium, in equilibrium. They are in equilibrium, but they are fixed to the wall. They are fixed to the wall. I don't care about these these points, because all of them are fixed to something which is very rigid. My concern is about the point in the air. This point is in the air. And this point will remain in this position under the effect of this force, and this force. So I can say this point in equilibrium. This is my concern. Any questions so far? Looks like we have two problems. If you remember what I did last meeting, just a second, like this one, we have a point with many forces. We have many forces at a point. So looks like I break this example to two problems, this one and this one. Okay? This is the most important part of the problem. And it's very easy. Only what you need to do, for the point that you are looking for, point D, just to go ahead. If you have a cable, we have a force. If you have a cable, we have a force. If you have a cable, we have a force. That's it. For the second point, C, we have a cable, so we have a force. Cable with a force, cable with a force. That's it. Nothing else. So we have two problems right now. I can start with point D and say summation of all x component equals 0, summation of all y component equals 0. Or I can start with point C and I can say summation of all x component equals 0 and summation of all y component equals 0. That's right. That's right. I do recommend to start with the point with the least number of unknowns. Go ahead and start with the part with the least number of unknowns. If you go back here and count how many unknowns, this one is unknown. This one is unknown. This one is known, 20. So we have two unknowns. If you look here, this one is unknown. This one is unknown. This one is unknown. So looks like we have three unknowns. So I'm gonna start with point D. I will start with point D with the least number of unknowns. Does that make sense? So I will start with 4 point D. Just a reminder, point D, we have a force in this direction, we have a force in this direction, we have a force in this direction. The vertical force is a weight 20 Newton. This force is called FDE. And this force is called FDC. This angle is given by 30 degrees. Do you remember what was the first step to solve this equilibrium problems? I will break each force to two components. Let's start with FDE with angle 30. So this force will be broken to two components, one horizontal, FDE cosine, one vertical, FDE sine. This is the first force. Second force. We have this force FDC. We don't have Y component. It's only X. We have another force 20 in Y. We don't have X. So this value is positive in X. This value is positive in Y. This value is negative in X. This one is 0. This one is 0 in X. This one is negative in Y. I will start to apply my equilibrium equation. Summation of all X component equals 0. Please put all components in X direction. This one, FDE cosine 30, negative FDC plus 0 equals 0. We have this component, we have this component, we have this component in X direction. Summation of all Y components equals 0. So we have FDE sine we have the 0, this one, and we have negative 20 equal 0. I forget this is not theta. This one is sine 30. So right now, I started with joint D with 3 forces only. One of them is 20, and the 2 of them are unknown. This point D, I started to break each force to 2 components. You are super lucky. You have only 1 force inclined, so I break it to 2 components. The other 2 forces are ready for you. I applied the 2 equilibrium equations. Summation f of x equals 0, summation f of y equals 0, so I can set up these 2 equations. Go ahead and solve these 2 equations. I'm super lucky one more time, because if you look to this equation, I can find something. I can find FDE easy. Your value of FDE will be 20 divided by sine 30. The value, I moved negative 20 to the other side, and then divided by sine 30. So I can find the value of this force equal 40 Newton. If you used this 40 for FDE and put it here, I can find the value of FDC. FDC will be 34.6 Newton. So the final conclusion, FDC equal 34.6, FDE equal 40 Newton. I can go back here and put FDC equal 34.6 and the FDE equal 40 Newton. So the force in this cable, 40. The force in this cable, 34.6. Guys, keep in your mind that the force FDC will be the same like FED. I'm sorry, FCD. 34.6. Why? Because both of them in the same cable. So same cable means same force. If you found the force in this cable from joint D equal 34.6, it must be 34.6 on the other joint. Does that make sense? So 34.6 is the value for FCD. They are the same. It's a good question. Thank you. I understand, and I'm aware of all questions in your mind. Yes, because they are in the same cable, they must be same value. So now I am ready for joint C. The second part of the problem, I will start a new part here for joint C. Here is joint C with horizontal force, inclined force, and another inclined force. This one 34.6. It's already done. 34.6. For this force FCB with angle 45 degree. And we have another force FCA with right angle triangle 435. This is point C. We have a new problem with three forces. This one is known, this one is unknown, this one is unknown, and this point is in equilibrium. So we have two steps. The first step, I need to break each force to two components. Let's start. I will start with the force FCB with angle 45 degree. So I can break this force to two components, one horizontal, FCB cosine, and vertical FCB sine, 45 degree. This direction is negative, and this direction is negative. What else? We have another force. This one, FCA. And this right angle triangle 435. Guys, be careful. I will break it to two components, one horizontal and one vertical. If you select your angle is here, if you assume your angle theta is here, so this angle will equal to this one. So if this is your angle theta, this component will be FCA cosine. And the other component will be FCA sine. From this right angle triangle, 435, and based on your selection of the angle theta, sine theta equal 4/5. The opposite for theta is 4. Cosine theta, the adjacent for theta is 3/5. So I can say, I can remove this part and put FCA time 3/5. I can remove this part and put 4/5 FCA. This direction is positive, this direction is negative. What else? We have one more force. One more force, don't forget. We have this force 34.6 in the positive direction for X. We don't have Y component. Do you have any more forces at joint C? No, we have only 3. I am done with all of them. Then I can start to say summation of all X component equals 0. We have one here, we have one more here, and we have one more here. Add all of them together. So we will have negative FCB cosine. We will have negative 3/5 FCA. We have positive 34.6 equals 0. And this is equation number 1. Summation of all Y components equals 0. We have one component here, we have one more, and we have 0. So negative FCB sign. 45 degree. Positive 4/5 FCA plus 0. This one equal 0. This is equation number 2. Go ahead. This is math. The next step is just math. Go ahead and solve these two equations together. I will help you to do this. For me, I will start with this equation. Equation number 2. I can say negative 0.71 FCB plus 0.8 FCA equal 0. Just sine 45 degree equal 0.71. And we have negative. 4/5 equal 0.8. Then I can say FCB will equal 0.8 divided by 0.71 FCA. I just moved this one to the other side. It will be positive. And the left is FCB alone. So the other side will be 0.8 FCA divided by 0.71. This is the first one coming from equation number 2. Go back to equation number 1. Negative. We have negative here. FCB. Anybody can tell me what is the value of FCB? This one. So I can put 0.8 divided by 0.71 FCA. This term or this expression represent FCB. Cosine 45 degree minus 3/5 FCA plus 34.6 equals 0. If you look to this equation, we have only one unknown, which is FCA. I can figure it out. So the value of FCA will be negative 0.8 divided by 0.71 times cosine 45 degree minus 0.6 3/5. Your value will be 24.8 Newton. 24.8. If you go back with FCA equal 24.8 and put it here, I can figure out the value of FCB. It will be 27.9. So the force FCB equal 27.9. And the force FCA was 24.8. This is your final conclusion. 24.8, 27.9. This is the required in this problem. What is the tension force developed in each chord? Chord CB has a force 27.9. Chord CA has a force equal 24.8. Chord CD equal 34.6. Chord DE has a force equal 40. These forces only to support your lamp of 20 Newton. Nothing difficult, but the problem is long, a little bit. You need to start first to set up your joints with the forces. This step is very important. Then you can divide your problem to two parts. I started with D and started to solve D as a separate problem. I put D and my forces. I break each force to two components. I put my equilibrium equation summation f of x equals 0, summation f of y equals 0. I set up two equations, solve them together to find out your unknowns. Second part, I have another joint with forces. I break each force to two components. I set up my equilibrium equation, summation f of x equals 0, summation f of y equals 0. I set up two equations, solve them together to find out your unknowns. Once you are done, your problem is done. What do you think? Looks good? This is a typical problem in this module. This is the typical problem in this module. Let's do one more example from your homework. I will do example number or problem number 4. I will solve it with you. Problem number 4. We have a bucket, this bucket with a weight. As you know, your weight must be in a vertical direction downward, 50 pounds. To hang this bucket, we have system of cords or system of cables or system of wires to keep this bucket in this position. Wire ED, EB, BC, and BA. My concern will be about point B and the point E. I don't care about A. I don't care about C. I don't care about D because these points are fixed in a hook. And this hook fixed in the wall. So they are fixed. I don't care about them. My concern is the point in the air, which is in equilibrium. This point in this position due to the effect of this cable and this cable and this cable. This point E at this position due to the effect of this cable and this cable and this bucket weight. So I have my concern is point E and the point B. This is the first step. You need to draw your joints. Let's start. With joint E, I will have this vertical weight of 50 pounds. I will have this cable FED with this angle 30. I will have this cable with the force FEB with right angle triangle 4, 3, 5. That makes sense? If you go back here, point E, we have this force, we have this force, and we have this force. Nothing else. Only these three forces. For point B, I will have this force FBC with this angle 30. I will have this force FBE with the right angle triangle 4, 3, 5. I will have this force FBA in a horizontal direction. We have two problems. One for E and one for B. Anybody can remind me which one I'm gonna start with? Do you remember what was the rule? We will start with the least number of unknowns. Go ahead and count. We have this one is unknown. This one is unknown. This one is known. So it looks like we have 2. For this one, at this moment, this one is unknown. This one is unknown. This one is still unknown. So we have 3 unknowns. So it looks like I will start with point E. I'm gonna start with point E. So in my calculation sheet, I will write here for joint or point E. I will start to, I will start to draw point E one more time. I have vertical weight, 50 pounds. I have a force in this direction and another force in this direction. This one is called FED with angle 30. This one is called FEB with 435. Let's start. I need to break each force to 2 components. So this force, FED, with angle 30, will be broken to 2 components. One horizontal, FED cosine, FED sine. This direction is positive. This direction is positive. What else? We have this force, FEB, with right angle triangle 435. This one will be broken to 2 components, one horizontal and one vertical. Be careful. Be careful. If you select this is your angle from the right angle triangle, I can say this angle is equal to this one. If this is your angle theta, so your component, horizontal component, which is adjacent to the selected angle, will be FEB cosine. And this one, FEB sine. From this right angle triangle, based on your selection, this is your angle, theta. This is 3, this is 4, this is 5. I can say sine theta equal 4/5. Cosine theta equal 3/5. So I can remove this cosine and put 3/5 FEB. I can remove this sine and put 4/5 FEB. This direction is positive. This direction is negative. What else? What else? We have this vertical force, 50 pounds. Is it 50? Yes, 50 pounds. We don't have any horizontal direction, and this vertical direction is negative. Do you have any more forces? We have only 3. I am done with the 3. I can start to write summation of all x component equals 0. All of them, please. We have this one positive, we have this one 0, and we have this one negative. So it will be FED cosine plus 0 minus 3/5 FEB. This is equation number 1. I'm sorry, I forget. Equal 0. This is equation number 1. Equation number 2, summation of all y components equals 0. We have one here, FED sine. We have one here, negative 50. And we have one more here, positive 4/5 FEB. So this one is negative, positive also. So we have positive FED sine 30 negative 50 plus 4/5 FEB equals 0. Equation number 2. Math step. Go ahead and solve these two equations together. I will help you to figure this out. From this equation, I can say cosine 30 equal how much? It's 0.86. So this is from equation number 1. 0.86 FED negative 3/5 is 0.6. FEB equals 0. So I can say FED will equal 0.6 divided by 0.86 FEB. I just move this term to the other side, then divided by 0.86 to put FED in one side and everything on the other side. This is from equation number 1. If you start to work with equation number 2, I can say FED, this term only, equivalent to this term. So 0.6 divided by 0.86 FEB. We still have sine, don't forget it, sine 30 minus 50 plus 4/5 FEB equals 0. This equation became in one unknown. FEB, I can figure it out. The value of FEB will be, just a moment. (43.5 Newton). Go back here and put FEB with this number, 43.5. I can figure out the value of FED. It will be 30.4 pound. Is it pound or Newton? It's pound. We are done. FED equal 30.4. FEB (43.5) pound. So this one, how much? 43.5, and this one 30.4. Keep in your mind, because these two forces are in the same cable, so EB will equal BE. So this value will be 43.5. Now I can start to work with point B. Start your calculation by writing 4 point B. Point B, we have a force in this direction, we have a force in this direction, we have a force in this direction. That's right. I'm sorry, it's not here. We have a force in this direction and one more. This one is 43.5. And this right angle triangle 435. This one is FBC with angle 30. This one is FBA. Go ahead and start your calculation one more time. I will break each force to two components. The horizontal one, FBA, is horizontal in the negative direction. We don't have vertical. For this force, FBC with angle 30, I can break this force to two components, one horizontal and one vertical. FBC cosine 30, FBC sine 30. And both of them are positive. What else? We have this force 43.5 with this right angle triangle 435. I need to break this force to two components, one horizontal and one vertical. Be careful. If you select your angle here, it's up to you. You can select whatever you want. If you select this is your angle, this angle will equal to this one. Based on your selection, this component will be 43.5 cosine, the selected angle. And this one will be 43.5 sine, the selected angle. From this right angle triangle, 3, 4, 5, and based on your selection, the value of sine theta opposite, 3/5. The value of cosine theta adjacent, 4/5. So I can remove this term and put 4/5. So the value will be 43.5 times 4/5 equal 34.8 in negative direction. I will remove sine theta and put 3/5. This term will be 43.5 times 3/5 equal 26.1 in the negative direction. Do you have more? I am done. We have 3. 1, 2, 3. I am done with all of them. Then I can apply my equilibrium equations. Summation of all x component equals 0. What do you have in x? We have this one, negative FBA. We have this component, FBC cosine 30. And we have this component, I'm sorry, this one is positive, not negative. I'm sorry. Plus 26.1 equals 0. Looks good. Summation f of y equals 0. What do you have in y direction? We have 0. We have this one. So 0 plus FBC sine 30 minus 34.8, this one, equals 0. We have two more equations with two unknowns. I think we are lucky here because if you start with this equation, I can get something. I can figure out the value of FBC, easy calculation. It will be 34.8 divided by sine 30. This value will be 69.6 pound. If you go back with FBC here and put it 69.6, I can figure out the value of FBA. It will be 86.4 pound. So FBA equal 86.4 pound. FBC 69.6. Pound. I am done. I found the tension force developed in each wire. This one, this one, this one, and this one. That makes sense? No difference between this force or this example and your homework problem. The same sequence. The same sequence. Also, there is no difference with this example. I need to figure out these 2 points, C and B. Here is B. Here is C. These are my concern. Let's start with C. For example, I have vertical weight of this cylinder, 30 pounds. This point C is hanging in this position using this cable and another cable. So I have FCB and I have FCD. The angle of this force will be 30. The angle of this force will be 15. That makes sense? For B, I will have this force, FBC, this weight, which is unknown for me. I don't know how much is this weight. And we have another force in this cable, FBA. This angle is given 45 degrees. This angle is given 50. So we have 2 problems. Exactly like we did in this problem, like we did in this example. That makes sense? One more time, if you want. At C, we have this vertical weight, we have this force, and we have this force. That makes sense? At B, we have this force, we have this force, we have this weight, which is unknown. Exactly. Then I will start with each point alone. Point B or point C. Which one I'm gonna start with? My rule is I will start with the least number